Welcome everyone, to today's presentation on accelerating your secure server using the TLS1.3 server IP core. We'll explore how the TLS10GS IP core can enhance security and performance throughout of your secure server in scenarios where CPU and software alone cannot compete. High-performance secure servers are designed to handle large volumes of data efficiently. However, ensuring security without compromising performance is a significant challenge. In secure connections such as HTTPS, TLS1.3 is implemented to establish a connection. TLS encrypts and secures data before transit between the client and server, significantly increasing the complexity for potential attackers attempting to intercept or read the data, thus imposing an additional task for both the client and server. In PC-based systems, the CPU is responsible for encrypting data before transmission across the network and decrypting received data for further processing. These cryptographic tasks can consume a significant amount of CPU resources, sometimes reaching 100% CPU usage, consequently affecting the transfer speed. For example, the transfer speed can decrease to 60% in half-duplex mode. In high-speed networks, CPU limitations become the bottleneck of the system and prevent the system from achieving the full bandwidth capacity for data transfer. DG offers the TLS1.3 10G IP core as a hardware-accelerated solution for implementing TLS1.3 over 10 gigabit Ethernet, effectively managing handshake, encryption, and decryption processes without CPU workload. By utilizing our TLS1.3 10G server IP core, the transfer speed on your secure server can be achieved to nearing 10 gigabits per second. Your CPU can seamlessly handle other tasks while ensuring security and high-speed data transfer, making TLS1.3 server IP core ideal for high-performance and highly secure servers. Let's see the key features of TLS1.3 server IP or TLS10GS IP. It includes support for cipher suites TLS10GS-IP, the key exchange using X25519, the key derivation with HKDF and SHA-384, with AES256GCM for encryption decryption, and RSA-2048 for certificates. And lastly, RSA-PSS-RSA-ESHA-256 for signature algorithms. Let's take a closer look at the transfer speeds for both half-duplex and full-duplex scenarios. When transferring data between the web browser and both Node.js server and TLS10GS, we observe a transfer speed of only 7,600 megabits per second, even in half-duplex mode. This limitation is attributed to the encryption and decryption processes occurring during data transfer. To optimize data transfer speed, we employ specialized test software as the client. This software is designed to separate encryption and transmission tasks during TX mode, and reception and decryption tasks during RX mode. In half-duplex mode, we achieve transfer speeds nearing 10 gigabits per second with 100% Intel i7 CPU usage. However, in full duplex mode, we observe a decrease in transfer speeds. This suggests that the CPU struggles to handle both receiving and transmitting tasks concurrently in a secure connection, thereby impacting the ability to maintain the 10 gigabits per second throughput. By leveraging DG's TLS10GX solution to offload encryption decryption tasks, we can effectively restore transfer speeds to nearing 10 gigabits per second in both full duplex and half-duplex scenarios. The performance summary is shown as a current comparison table. Our TLS1.3 10G server IP core can free up the CPU for other essential tasks and can achieve nearly 10,000 megabits per second with our TLS1.3 IP core on both the server and client side. Let me example applications. The aerospace telemetry is one of the most mission-critical applications that needs to ensure the integrity and confidentiality of sensitive in-flight data streams from space remote sensors to ground storage. FPGA accelerated TLS1.3 outpaces software-only solutions, safeguarding critical flight information. Another example is the medical device connectivity. To protect highly confidential patient data in transit between medical devices and healthcare or data storage systems, our TLS1.3 IP solution can provide the robust encryption and authentication mechanisms needed to comply with stringent healthcare regulations and safeguard patient privacy. Now, let's dive into the practical demonstration of TLS10GS on the ZCU102 FPGA board. Through this demo, we'll showcase the functionality and performance of TLS10GS in real-world scenarios, including interactions with PC-based clients and other FPGAs. Our demo setup features an FPGA board equipped with TLS10GS IPcore, connected to a 10 gigabit Ethernet network. During the demo, we'll showcase how users can interact with TLS10GS demo using a web browser, transfer data with a specialized client application, and compare performance across two FPGA boards. Users can configure network parameters and the server certificate, and set RSA private key via the serial console. TLS10GS demo is designed to show that TLS10GS IP can handle a TLS1.3 connection similar to the example Node.js server. TLS10GS demo is capable of receiving a data pattern from the web browser and displaying the TLS payload. This mirrors the process where the Node.js server receives data from the web browser. Users can request data via a web browser's GET command, displaying results identical to the Node.js server's response. During large data downloads, transfer speeds may decrease due to encryption and decryption processes. As you can see, the transfer speed reaches only 954 megabytes per second or approximately 7,600 megabits per second on a 10G Ethernet connection. We'll employ a specialized client application optimized for peak throughput to analyze the transfer speeds. The client application is designed to encrypt data before transmission through the network in TX mode, decrypt the last data block, and verify the total received data size after finishing reception in RX mode. This refined approach ensures that the CPU doesn't simultaneously handle encryption and transmission tasks during TX mode, and reception and decryption tasks during RX mode. Through half-duplex, download-upload, testing, we observe transfer speeds nearing 10 gigabits per second, accompanied by near full CPU utilization, as monitored by the PC's task manager. For full duplex mode, we'll observe a reduction in transfer speeds between the client application and TLS10GS demo. This decline suggests a CPU limitation in handling simultaneous reception, transmission, and cryptographic tasks, consequently affecting the maintenance of throughput at the targeted 10 gigabits per second level. To break CPU limitations, we conduct transfer speed tests between two FPGA boards. TLS10GS demo, implemented on ZCU 102, serves as the server, while TLS10GC demo, implemented on ZCU 106, operates as the client. This setup allows us to evaluate the performance of TLS10GS in a real-world scenario, free from CPU constraints. By offloading cryptographic tasks entirely to hardware, including encryption and decryption, we achieve a remarkable throughput of 9,360 megabits per second, representing the maximum achievable throughput with TCP/IP in this demonstration scenario. Enhance the security of your server while maintaining high-speed data transfer with DG's TLS10GS IPcore. Our solution handles TLS1.3 handshake, encryption and decryption without compromising performance. For more information, please contact us. Thank you for watching.